2025 didn't go as planned.
535 मार्क्स, बस थोड़े से मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P²CB, जिससे फिजिक्स पे होगा डबल फोकस। Don't just make it your last try, make it your best one yet. Join Infinity Learn today.
Hello, good afternoon, my dear students. Welcome to one more amazing session from Infinity Learn. How are you all doing? Please confirm. Am I audible? You can see me, you can hear me. Just give a confirmation in the chat box. Hello. Hi, Anisha. Good evening. Good afternoon. Yeah. So, today we are going to discuss about the classification of the periodic properties in the classification of the elements. So far we have seen the history of the periodic table, how the periodic table has been classified into different blocks and the general electronic configuration and all. Definitely you can expect one question from your examination based on this particular topic. Yeah. So before going for this session 3, I just want to give a promo about program Atreya, and it is a program conducted by Infinity Learn by Sri Chaitanya Academy, where you can see this is a special program Atreya for droppers. While this droppers program, you can see we are going to make a transformation from I didn't do to I will do it. So the best well designed program, crack your NEET examination, introducing Atreya, India's most powerful NEET repeaters program, where you will be given emphasis more on the physics, and this program is a P²CB, where physics twice a day and chemistry and biology. As you know, everybody, physics slapped like anything in your NEET 2025. So this is a universal problem for all students preparing for NEET examination, and physics is the nightmare. So Infinity Learn want to come out with a better resolution and introducing Atreya. And in this Atreya program, you can say revolutionizing NEET preparation with P²CB, double focus on physics with chemistry and biology. Now enroll now, and link is available in the description box. You can do is the best. And let me shortly explain you the total program over here. This batch commencement from May 23, and when you join freshly, definitely a new series of batches are being introduced, and you will be allocated in a new batch, and the batch incepted in 2023. Okay, so 23 May, and we have the classes, concept class along with the practice classes Monday to Saturday all hour, and each class is 1 hour 30 minutes. It's a 90-minute session. And while classes per day, 3 classes per day, and in that 2 concept classes, 1 practice session. Mind it, this practice session is double with the physics. 18 classes per week and double practice classes for physics. That is very, very important point. So when the practice is happened in the double, you are going to do the best for your NEET examination. So you will understand your problem, and you will understand the problem solving ability, and you will be strengthened in your physics. Anisha, right? And those who are in the chat box on the live, you can just talk to me. It is a live interactive session. And you see 465 live interactive classes by experts, and 240 DPPs, and dedicated practice class, near about 120 plus hours practice classes, and after each and every class session, notes will be there. So actually, Anusha, sir, NEET result will be announced after final answer key, or directly it will be released. And there is a chance only before going for this final answer key release. Actually, answer key should be finalized, then only result should come. And the finalized answer may be published or may not be published. That's the reason why you can expect the NEET result maybe today or tomorrow or day after tomorrow. Expected date is June 14th, but you can expect anything anytime before that. It can come in the morning, afternoon or evening. Get ready for that, right? So don't worry about NEET final key, because NEET final key, it makes it all challenges, but the key is almost finalized. Okay, that's fine. So you have after classes revision notes in the PDF format will be given in the website itself and the portal itself, dear children. And coverage of total NEET syllabus based on the 11th and 12th will be done. And very important point here, batch size for the practice is going to be 20 to 25. That is the powerful tool. Okay, when this is batch size is 20 to 25, what happens, you will be having a chance to interact with your faculty, and you will be having an customized doubt clarification. So faculty will have a very good focus on you when the batch size is very less. In the practice session, it is very important. That's the reason why we want to give the more emphasis for P square CB program. It is the revolutionizing program. Dear children, let us start. Our promotion is over at last, and only 2 days officially left for your NEET result, NEET 2025. If you want to see the predict the rank or the college of your choice, you can just enter your details so that you will be having the automated analysis. So if one has not challenged some questions, but some other children did so it well, the fruitful for all OMR, the one who challenged only. No. Let us say question number 60, the key released is option C. If somebody like you is challenged as option A, so that will be scrutinized, and expert team is going to finalize whether it is C or A. Okay, if they finalize according to challenge as A, it is going to be applied for everybody, not only for the challenged persons, right? Anisha, you got your answer there? Fine, nice. And let us say, and talking about periodic table and periodic properties, so far what happened, and you can keep asking doubts in between, so that we will be giving an insight of how the doubts will be there for the students and how we are going to do. And we have seen the developments and the classification of the elements, and we have seen the modern periodic table and systematic nomenclature. These are the things which we already completed, right? So अगर कुछ डाउट है ना, तो ये टॉपिक में एक बार आप पूछना है, so that I can answer your questions, right? And talking about here, and today's class, atomic radius, screening effect, and ionization energy, and the 3 topics I just want to take into the consideration, and definitely you will be having a question based on this. So इस session का एक बार like मारो and share with your friends and subscribe to Infinity Learn YouTube channel. Okay, Anisha, आज का session like दिया? You like it today's session? I just want to see number of likes, concurrent viewers, chart, everything I can see in front of me. Anisha and all students, please like the session. I want to see the numbers out there. Come on, let us talk about atomic radius. So classification of elements can be done on the basis of metals, non-metals and metalloids. Yeah, metals, thank you Anisha, metals, non-metals and metalloids. So let's discuss about the variation among these 3. And you can see the metals, most of the elements in the periodic table are metals only, you can see. And a few are metalloids, and remaining things are going to be non-metals, right? So what makes the difference between the metals and non-metals and the metalloids? Metals and non-metals and metalloids. You can see, dear children, here there are nice animations are being created for you guys. Now you can see metals, they are very good conductors of heat and electricity, and they have a metallic luster. Usually they are solid and they are malleable and ductile. And you see, can you say a liquid metal? One liquid metal, it is mercury. So students are going to ask me, sir, what about the cesium, sir? Cesium is a liquid metal, yes. And mercury is a liquid metal, yes. And you know, there is one thing, this is a magic metal, gallium. Gallium is a solid. When you touch and put it in your hand, just like a butter, it melt. So gallium is a liquid when you touch it, because the temperature of the body temperature makes that metal going to melt in your hand only. So talking about the metals and non-metals, they have the low ionization energy. You have very active metals, very unreactive metals. Very active metals, sodium, potassium, rubidium, cesium. Unreactive metals, okay, you can take platinum, right? Okay, so non-metals, let us say they are poor conductor of electricity, so they are insulators. Could you say the non-metal which can conduct electricity? The non-metal which can conduct electricity? Anybody? A non-metal which can conduct electricity. A non-metal which is a very good conductor of electricity. I want to know from you. I want to know from you, dear children. Carbon, graphite allotrope is going to be very good conductor of electricity. Yes? Anisha? So, like twists and turns are there. And their non-metals are brittle and vary in colors. So, non-metals has a color. Yes. Non-metal has a color. Can you tell me the color of the non-metals? Color of the non-metals? Fluorine, pale yellow. Chlorine, pale green. Bromine, it is going to be red, blood red liquid. You know? Okay, anyways, they have very high ionization energy. They have very high ionization energy. And you have metalloids. And you have metalloids, they are semiconductors. And their dull, brittle properties depends on the conditions. If temperature changes, the conductivity also changes. Understand? Clear? Any doubts? Let's see the periodic properties. So, which general electronic configuration of the element does not represent a non-metal? A, B, C, D. A non-metal. Wherever p block elements are going to be non-metals. Wherever p block element is going to be a non-metal, d block elements, total d block elements are going to be metals. So, this is a general electronic configuration of a non-metal. Are you getting or not? Clear? Fine. So, like that, the electronic configuration is connected to the questions. Like these questions only you are going to see in the NEET examination and any other competitive examinations, my dear children. Okay, let's talk about trends across the periodic table. You can see the trends across the periodic table. You have atomic radius, ionization enthalpy, electron affinity, you have electronegativity and metallic character and non-metallic character. Are you getting or not? Ahmad, hi, hello, how are you? So, are you attending the classes regularly, Ahmad? Yeah. So, let us focus here in today's class is going to be atomic radius. Yeah, I got 460 or 450 marks, okay. Let's see how you are going to get a result. Maybe tomorrow, mostly I am expecting on June 14th on hours per time, okay. So, ab jo bhi kiya, acha kiya. So, nothing is there in your hand. So, just see and enjoy your result. If you get it good, wait for counseling. If the counseling doesn't favors you, you just follow our NEET repeaters program Atraya. So, session ke ek baar like maro. Ahmad, session ke ek baar like maro beta. Well, so let's talk about the atomic radius. So, in the atomic radius, what is the meaning of atomic radius? Various types of atomic radius are there here. Covalent radius, metallic radius, van der Waals radius and the ionic radius. Right? Van der Waals radius and ionic radius. So, these are the various types of atomic radius we have to study. Why these many types of atomic radius? So, these many types of atomic radius you have to study because of the atom. If you consider as a sphere, you don't have a clear-cut boundary. You don't have a clear-cut boundary. That's the reason why you have to use as they have the bonding. So, moving into what exactly the atomic radius. So, there lies its secret. What exactly is atomic radius? Here you can see the atomic radius. It is defined as the distance between the center of the nucleus and outermost electron. So, the distance between these two you can't take it, because you can't go inside the atom, take the center of the nucleus, and you don't have a proper boundary for the atom. So, you can't go here, and this is not a precise boundary. The electron is a wave, it has a cloud, okay, you don't have that value exactly. So, for that one need to know. So, but we can say find the distance between the center of the atom and its outermost shell. Is it possible? Bacho, ये possible है कि ना? Let's see. So, finding the size of an atom is a lot more complicated process बेटा, क्योंकि इसका value जो है, the size of the atom is in the range of 10 power minus 10 meters. It is very small, and there is no clear-cut boundary where the outermost electron can exist, right? And that's why we estimate the atomic radius in the combined state. When it is formed, the combined state, it forms a compound. It could be a covalent compound, it could be ionic compound, it could be metallic packing. Okay, it is called various types of the bondings gives rise to various types of the definition of the radius. That's very important, bacho. Now we can see how to estimate the atomic radius. This is a very important understanding slide, bacho. Now you can see when it's possible to find out the atomic radius is to use internuclear distance. When you take the internuclear distance between two atoms in the type of bond, like for a non-metals, as we know the non-metals forms a covalent compounds, so that covalent compounds has a covalent radius, right? Similarly, you have a metals are going to combine and form metallic crystal, so that you have metallic radii, a metallic radii also said to be crystal radii. Okay. And when you see the noble gases don't form any kind of bond. Only noble gas atom and noble gas atom बीच में van der Waals forces of attractions भी होगा. So inert gases cases में आपका van der Waals radii consider करना पड़ता. And between the cation and anion, this is the ionic compounds, we have the ionic radius. You have various types of radius we are going to study. Ahmed and Anisha, hope you are understanding. All the students who are online, you please confirm. Okay. Hi Nawal, hi, how are you? Nawal Singh. So enjoying the slides, better slides. So these slides we make because we are doing a lot of hard work and doing the best. Okay. Hope you like this. Nawal, if you like these slides, please hit the like button, so that I will be very happy. So it is graceful to you. And how to estimate the atomic radius. So you study covalent radius, metallic radius, van der Waals radius, and the ionic radius in general, right? So let's talk about this covalent radius. So when you take a covalent molecule like this, covalent molecule is formed by the mutual sharing of electrons between two atoms. Yeah, fine. Then hit the like button. Now when this atom, you can see this atom and this atom is uniting. So the distance between this nucleus and this nucleus is called internuclear distance. Okay. And 1/2 of the distance between the centers, that is going to be d, and covalent radius is going to be d by 2. Okay, this is very, very important. It is going to be d by 2. Are you getting or not? Clear? That's fine. And it is generally used for non-metals. You can use the picometers, you can use the angstrom units. Okay, 1 angstrom unit is equal to कितना होगा बेटा? 10 power minus 8 centimeters. 1 picometer is equal to 10 power minus 12 meters. Okay, so these are the various versions, right? Now let us talk about the next, metallic radius. This is also called as a crystal radius. So when the metallic crystal is seen like this is a metal atom and this is a metal atom, almost they are in contact. Rather, you can write this as a metal and this as a metal, and the distance between these two is said to be d by 2, and this is going to be d, and radius of the metallic is going to be d by 2. They should almost in touch. They should not be completely separated out. Understand? Understand? Any doubt, please let me know. Yeah. So, when you talk about this, we use the term atomic radius to refer both covalent as well as a metallic radius depending on whether the element is a metal or a non-metal, right? But atomic radius means this is only either covalent radius or metallic radius. And when we move to this van der Waals radius, so let's talk about the covalent radius and the metallic radius. It is the half of the distance between the centers of two nuclei between two non-metals bonded by a single covalent bond. You have to take the single covalent bond. Okay, if it is similar atoms, if it is dissimilar atoms, you have to put electronegativity into the consideration. And metallic radius is half the internuclear distance between two atoms separating in the metal cores in the metal crystal. And overlapping of two off-filled atomic orbitals are there in the covalent radius. Here no overlapping despite the atoms being in contact. Okay, so there is an electron C theory in the metallic bonding explanation we can say. So please do like the session and enjoy the session with beautiful animations and valuable content, my dear children. And stay tuned. In the Nirman series, we are doing the best for the students from our Infinity Learn, and this YouTube channel is full free of cost. You just attend the class and enjoy the lesson. And we don't expect anything except expect just only one like and a share and a subscribe. Okay, subscribe kar lo ek bar. And talking about the trends in the atomic radii, before going for the trends, I just want to say here one thing. We'll talk about van der Waals radii. You have atomic radii, completed covalent radii, completed metallic radii. Now we are into van der Waals radii and ionic radii. Then I go to the trends, right? And you can see here van der Waals radii. It is defined as a half the interdistance nuclear distance between two non-bonded atoms, the separate entities, it between two molecules and between two atoms. Generally noble gases behave like this. Noble gas, let us say helium, and it is a helium, and they are not in bonding, they are separated apart, and there is a, you can say, van der Waals forces of attraction between these two, and it is a weak van der Waals forces. When this distance is said to be d and radius of the van der Waals is going to be d by 2. सबका d by 2 है होता है, उसमें खास बात नहीं है. Understand? And van der Waals radius does not apply to the metals, mind it. And its magnitude depends on the packing of the atoms when the elements in the solid state. Okay? And you can see, remember one thing, van der Waals radius values is always greater than metallic radius values is greater than covalent radius values, and van der Waals radius values are 40% greater than covalent radius values. That's very important. Based on that, you can compare these values and you can predict it. Okay. And let us talk about the ionic radius. The ionic radius can be estimated by measuring the distance between the cation and anion in the ionic crystal. When you talk about this is the ionic sodium chloride crystal packing, in that cation and anion is separated and studied like this. and this is a cation, and this is the anion, and this is the radius of the cation, this is the radius of the anion, and this is the distance. So you can say internuclear distance is 2, and this is the radius of cation, this is your radius of anion. And if you talk about the isoelectronic species, a cation is smaller than its parent atom because it has a very few electrons, while its nuclear charge remains the same. So the increase in the effective nuclear charge makes it is a small, while the size of anion is going to be larger. Here it is going to be the smaller, you need to say, than that of the parent atom, because the addition of one or more electrons would result in the increased repulsion among the electrons and decreased effective nuclear charge. So the internuclear distance is equal to the sum of the cation radius and anion radius. Understand? And you can say ionic radius, you can say a lithium is bigger and a lithium plus is smaller. Sodium is bigger, sodium plus is smaller. Are you getting or not? See the size of the atoms out there. You can see the bromine is smaller and a bromide ion is going to be the bigger. So I want to say generally the cations has the smaller size and anions are the larger size as compared to their neutral atoms. That's a very important noteworthy point, my dear children, right? Let us go more beyond this. And ionic radius, you see, the size of ion increases as you go down the group. Of course, we know that. And charge is same. As long as the charge is the same, size is inversely proportional to positive charge. अगर positive charge बढ़ते रहते हैं, size decreases. Okay, Nawal Singh, Anisha, Ahmad, I want you to be more interactive in the class. As compared to the anions, you see size is directly proportional to negative charge. This and these are the noteworthy point. This is a noteworthy point. This you can use as long as the number of shells are same. When you decide the order of the size, I just want to give you a trick. Trick number 1, rule number 1. I just want to say rule number 1. Just see the size is directly proportional to number of shells. As the shell number increases in its electronic configuration, the size is going to be increased. And rule number 2, it is going to be size is inversely proportional to positive charge. For the cation, size is directly proportional to negative charge. And if you have to use the rule 1, then only you can use rule 2. Rule 2 can be used when the shell number is same. Okay, this is applicable for isoelectronic species. The ionic radii of isoelectronic species decreases with increase in the magnitude of the nuclear charge. Bachcho, here in the Infinity Learn NEET YouTube channel or Infinity Learn any channel, genuine subject is going to be discussed. So we don't want to conduct the session just like managing the session in a colorful way. Rather, we'll give the subject in a depth. Okay, please like our session and please subscribe to Infinity Learn channel so that you will be having what session is going to have the next session. If you subscribe it, bell button above, so you will be getting automated updates. You will be getting an automated updates. Are you getting or not? Wonderful. Now we can see positive charge as negative charge increases, size increases for isoelectronic species. What are isoelectronic species? Just type in the message box. What are isoelectronic species? Bachcho. Isoelectronic species. The species which has the same number of electrons. That is what exactly I want to the interactive class. You want to have this kind of classes, you need to go to the coaching centers and have to pay huge amount of money, but you can just attend this class for the free of cost. Please take this as an advantage and you conduct the NEET examination. You can prepare it. Yes, ये YouTube channel में सही होगा. These YouTube sessions are sufficient to be a very good score in NEET examination. You will get a very good score, not even score, you can be a topper as well. Hazim, 561. You are going to get 561? Really? Very good. Congratulations. 561 is going to be very comfortable score, you are going to get it. Okay, and comfortable rank as well. You can have all India quota as well. As compared to the previous year, this year you can expect 20 to 30 marks for the cutoff, less marks for the cutoff. Okay, less marks for the cutoff. ठीक है? Fine. Now ionic radius for isoelectronic species beta is important. Now you can see atoms and ions which contain the same number of electrons are called isoelectronic species, whose radius would be different because of their different nuclear charge. Okay, so in cation, the greater the positive charge will have the smaller radius, and because of the greater attraction of the electrons to the nucleus. My dear children, you can take this as assertion and you can take this as a reason. You can expect assertion reasoning type questions also in the NEET examination, right? And anions as the greater negative charge will have the larger radius, so it is going to have the assertion, and you are going to have net repulsion of the electrons will overweigh the nuclear charge and the ion will expand in size is going to be the reason. So assertion and reasoning type questions you can track from the content itself. You can track from the content itself. You agree? Now let us move ahead. Remember one thing. So here size of anion is always greater than size of the atom is greater than size of the cation. And for the same atomic number, for the same isoelectronic species as well. And okay, coming to going back to the periodic trend over here, periodic trend, how it is going to be changed. Yes. So trends in the atomic radii, bacho. Trends in the atomic radii. When you talk about the atomic size decreases across the period and atomic size increases down the group. You can say in the periodic table, down the group number of shells increases. As number of shells increases, size of the atom increases. Understand? So size increases. And across the period, it is going to effective nuclear charge increases. Across the period, size decreases. Simple reason. Understand? Simple reason. And you can see various things. Variation of atomic radius across second period. So as I said, across lithium, beryllium, boron, carbon, nitrogen and oxygen and fluorine. And in any period, the respective alkali metal is the first element, is the largest element. There also you can crack one question. And leaving the noble gases, halogens are the small in the respective period. When it coming to the atomic size, we take either covalent radius or metallic radius. You don't consider van der Waals radius when it is generalized as it is an atomic radius. That's a very important point. Now you can see variation of atomic radii for alkali metals and halogens. You just see here alkali metals, are the large and alkali earth metals are going to be the small. Okay, when you say lithium smaller, potassium and sodium and potassium, rubidium and cesium, you can see there is an abrupt increase in the size of the potassium due to the vacant d orbitals. So that you can say because of the vacant d orbital, size is abruptly increased. When you say the similarly here, fluorine, chlorine, bromine and iodine. Iodine is the largest non-metal and cesium is the largest metal. Okay, lithium is the smallest alkali metal. Are you getting or not? Clear? And the size of the transition metals are small as compared to the size of the S block elements, alkali and alkali earth metals. So various noteworthy points I am just presenting here. You just follow, dear students. And yeah, now talking about, there are trends of atomic radii broadly depends on two things. One is effective nuclear charge, another one is shielding effect. So let's talk about the effective nuclear charge. This is the last electron attracted by the nucleus. But the thing is, what happened? The inside this electron that lies between the outermost electron and the nucleus act as a screen or shield. Okay, so that they start making a repulsion. So that effect is called as a screening effect or shielding effect. Both are same, screening effect and shielding effect. As a result of this effect, so this outermost electron experiences resultant nuclear attractions, and this is what is called as effective nuclear charge. That is called effective nuclear charge, symbolically represented like this. When you say symbolically represented like this, if effective nuclear charge is more, atom is going to be small because the electron is more close to the nucleus. And I just want to say, size is size, if Z effective increases, size decreases. Rather you can say that size decreases, you can say Z effective increases, size decreases. When shielding effect increased, the electrons that lies between the nucleus and the outermost shell act as a shield or a screen. Because of that, nucleus cannot attract the outermost electron effectively, so it is going little away. So as screening effect or shielding effect increases, size is going to be increased. Mind it, this is a super important awesome point. Are you getting or not? Clear? Any doubt? If you have any doubt, please let me know. So this is the point where many questions can be cracked based on that. Okay, many questions can be cracked. Yes, moving ahead. Bacho. So let's see how atomic radius is dependent on shielding effect and effective nuclear charge by observing the trends in the atomic radius. Here, atomic radius in a particular group increases from top to bottom. That's the rule number one. And down the group, principal quantum number increases, the number of shells increases, atomic radius increases down the group. The inner energy levels are fully filled with elements, electrons, which serve to shield the outermost electron from pull down the electrons from the nucleus. So we can say variation of atomic radii in the period. Shell is constant, number of shells are constant, so that electrons are coming close to the nucleus, so that atom is going to be decreased across the period. That's what I explained here, right? Anisha, come on, you kept quiet, talk to me. And Hazim and Nawal Singh, Ahmad, I want to see you. Your doubts. Okay, now atomic size. Moving across a period, atomic size should decrease, but the size of the group 18 elements are observed to be larger in the period. Why? Because you have the van der Waals radius, but the values that is measured by van der Waals radius parameter is 40% bigger. 40% bigger. As radius of van der Waals is greater than radius of metal is radius of covalent, and based on this, so many times various multiple choice questions are given in this competitive examination world, right? And atomic radii, we have covalent radii, metallic radii, van der Waals radii, ionic radii, we completed that also, right? Let us see the trends. Already these are the completed. Ionic radius are also shown here. Okay. So remember, I already given size of anion or size of atom. Now you just say which of the following species would have the smallest size. You have magnesium 12 electrons, 10 electrons, 13 electrons, 10 electrons. So when you talk about the isoelectronic species, the size is going to be aluminum 3 plus smaller than magnesium 2 plus smaller than magnesium and aluminum. So the smallest size is going to be aluminum 3 plus. My answer for this question is going to be aluminum 3 plus. Understand? Clear? Which of the following has the largest size? नेगेटिव चार्ज जिसका बड़ा है उसका साइज बढ़ते जाएगा. सो दैट लार्जेस्ट, ओके, isoelectronic, I just say beryllium 2 plus, lithium plus, and helium and hydride ion. Hydride ion. Understand? That's good. Which of the following orbital has highest screening power? Screening effect. Screening effect. S orbital is greater than, P orbital is greater than, D orbital is greater than F orbital. Among all 4s orbital is the one. And screening effect increases as n value decreases. And talking about the species, argon, potassium plus and calcium 2 plus contain the same number of electrons in which the order do not do their radius. You tell me the answer. I want to see your answer in the chat box. Come on, jaldi. Make it fast. Make it fast. So here calcium 2 plus, potassium plus and argon neutral and plus 1 and plus 2. That is the order you need to follow. So involve in this activity so that you will be having an attitude to develop. So कौन सा आंसर पकड़ना, जो भी गलती होने दो. So I am here to correct you, right? Now let us say, what do you think is the trend in the atomic radius we move along the third series? So we will discuss that. Now it is going to be 3D series. In the transition series, atomic radius of the elements decreases from left to right across a row until near the end, whereas the size increases slightly because d orbital is completely filled there. Now we can say in the 3D, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel. So up to D5, this is manganese D5, it is going to be decreased up to D5, half of the transition series. Then you can see it maintain a constant and there is a slight increase, copper and zinc. Now what happened here, Z effective nuclear charge is greater than screening effect. So atomic size decreases. Now up to here you can see effective nuclear charge is going to be overcome with screening effect. As I said, effective nuclear charge makes the atom to contract, become a small, and the screening effect makes the atom to become bigger. There are two factors. One factor is dominating the other factor. That's the reason why size is decreasing. When these two factors are both are just fighting together, so that the size is going to be maintained almost same. And here as D10 configuration comes into the picture, screening effect is going to be overridden by effective nuclear charge. So that as screening effect increases, size of the atom is going to be increased. Now this is a super awesome interpretation, and here iron, cobalt, nickel has nearly same atomic radius. So based on this, you can say a question from these competitive examinations can be expected. Getting or not, bacho? Clear? Right. So moving ahead, d orbital contraction, that's what it is said. On passing from the left to right, effective nuclear charge increases, hence the contraction in the same size occurs. And d orbital has a poor screening effect, hence d orbitals screen the outer electron, that is 4s. So from the inward pull of the nucleus, but not that effectively because of the screening effect. So hence it is called as a d orbital contraction. So that is what is happened up to the manganese. Effective nuclear charge is more effective as compared to the screening effect. But after D5, electrons are start pairing up. So once the electron is pairing up, their screening effect comes into the picture. Effective nuclear charge and screening effect both are going to be equal, and the atoms are going to be same, almost same. While if you say zinc and copper, you are going to see the d orbitals. When the d orbital is completely filled, screening effect is going to be more overweight than the effective nuclear charge. That's the reason why we have this. Understand, this is what is explained. And you can say atomic radius of d block elements, you can see 164, 147, 135, 129, 137. And here iron, cobalt, nickel nearly the same value. It is decreased, you can see it is decreased, right? And after that it is going to be increased. Zinc and copper is going to be increased little like this, okay? And Kushal, yes, so that's what it is exactly happen when it is a scandium D1, Kushal, right? You can see D2 and D3 and D5 and D5. So 4s2 and 4s1. So as the electrons are filling in the d orbital, so what is happening? Effective nuclear charge is going to be increased as compared to the screening effect. That's the reason why from here to here atomic size is decreased. Kushal, fine. Yeah, Anil, very good. And here effective nuclear charge is going to be nearly exactly the same with the screening effect. That's the reason why they have the almost same value, you can see. Kushal, you understand? And after this D10 configuration is there. Because of the D10 configuration, screening effect is going to be overweight the effective nuclear charge. Screening effect makes this size is going to be increased. That's the reason why this graph comes like this. So here size, radius, it is going to be slowly decreased and nearly the same, little bit increased. It happens in the case of any transition series. Okay, Kushal, hope you understand. Anil, Namanshi, Hi, please like these animations and session delivery, and I want to see number of likes during the session. That gives me a lot of encouragement when the session is going on. Okay, Anisha, you have any doubts? So I just want to see. Yes, thank you very much, Anil. Wonderful. And radius of aluminum and gallium, exception cases, whenever exception cases are there. So like the session. Thanks, Navashi. Thank you very much. Anil, I want to see you. So the radius of the gallium has slightly smaller value than radius of aluminum, and because d orbital contraction, that's very, very important. Okay, we'll discuss this. Yeah, discuss this in the p block elements especially, and we'll go ahead here. Ionization energy, in the next point it is going to be ionization energy. It is defined as the minimum energy that required to remove an electron from an isolated gaseous neutral atom. So 480 for 580 is a bit, or worst rank? No, 580 is going to be very good rank. You are going to get Utsav Kant. Utsav. So your all doubts are going to be answered. So students, of course, you are asking a question out of this context. Still, I am ready to help you because you have the more eager to see your result. Henam? Yes, you are going to get a relatively better rank and is clear good rank. Okay, definitely if it is 580 पक्का होगा तो मेडिकल सीट गवर्नमेंट मेडिकल कॉलेज में मिलेगा बेटा. ठीक है, फाइन. Right. So D is the amount of energy that required to remove, let us say, a metal which is in the gaseous state, an isolated gaseous neutral atom is going to be metal in the gaseous state and positive बनेगा, electron छोड़ के ये वाला ionization energy होगा. So units are going to be kilojoule per mole or kilocalorie per mole or electron volt per atom. Okay, electron volt per atom. And this value gives you very good insight about the behavior of the atom and element. And ionization energy, it is a quantitative measure of the tendency of an element to lose the electron is given by its ionization energy, behavior of the element. Smaller is the ionization energy, easy tendency to lose electrons. Larger is the atom, greater, so smaller is the ionization energy value. Bigger is the ionization energy value, less tendency to lose the electron. And smaller is the ionization energy, easy for the neutral atom to change itself into a positive ion. You have various types of ionization energies. So this is the first ionization energy. For loss of first electron from the neutral atom is called fast ionization energy. If we want to remove one electron from this already positive charged one, that is called as for second ionization energy. So if you say here a metal in the gaseous state, element, M is an element, is going to be M plus in the gaseous state by the loss of electron, and it is going to be ionization 1, and you want to do, this is unipositive ion, it is going to be M2 plus an electron, and it is going to be second ionization energy, and it is going to be M 3 plus, and this is going to be third ionization energy. Okay, so how it is related, these values, how these values are related, you tell me quickly. Always for an element what happened, IE1 is less than IE2 is less than IE3 and it is less than, and it is so on. Are you getting or not clear? Are you getting or not clear? That's fine. the first ionization enthalpies of the elements in the second period, let us say. So, the lithium, beryllium, magnesium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Across the period, ionization energy decreases. But here, what I expected here, look at this. So, you can say lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine and neon. This is the actual order. This is the actual order. Carefully you see. So, when you talk about this beryllium, it has 2s2 configuration. Because of this 2s2 configuration, it is 2s2 2p1 configuration. Because of the electronic symmetry, beryllium is higher ionization energy. Because of the loosely bonded electron, the boron is relatively lower side of the ionization energy. That is the reason why there is an abnormality here. Beryllium is greater than boron. Beryllium is greater than boron. Are you getting or not? Clear? Beryllium is greater than boron, you can see. And similarly, boron, carbon, nitrogen and oxygen. Because of this nitrogen electronic configuration, it is 2s2, 2p3 half filled electron configuration, 2p3 half filled electron configuration. When the orbital is completely filled or half filled, you are going to have the higher side of stability. Because of the higher stability, it is going to be exceptionally greater ionization energy, and this greater ionization energy makes it exception. So, this is the exception here. Beryllium is greater than boron, and this is an exception. Nitrogen is greater than oxygen. So, you can get a question based on this particular context, even in the graphical side and even in this logical side, and the reason also mentioned. You can get a question from NEET examination or any competitive examination, like assertion, reasoning type questions, statement based questions. Like that, you have to prepare your NEET examination so logically instead of book bugging type, mugging up type. रट्टा मत मारना, लॉजिक पकड़ने को कोशिश करो बेटा. Okay, what's up? Fine. Anil, Nawashi, Kushal, guys, you are able to understand carefully. You understand this. And moving at first ionization enthalpies of alkali metals, you can say lithium, sodium, potassium, rubidium and cesium. Dear children, here you can say down the group, of course, ionization energy is going to be decreased. Down the group, ionization energy is going to be decreased, so that lithium is going to be greater than sodium, is greater than potassium, rubidium and cesium. Now, you can see the graph is coming down only, but I can say there is an abrupt jump over here. Sodium and the potassium. Potassium is having less ionization energy, lesser ionization energy compared to expected values. Why? Because d orbitals, due to d orbitals, right? So, wherever exception is there, see, suddenly there is a decreasement, suddenly there is a decrement. Are you getting or not? Clear? Yes. Moving ahead here about the periodic property of the ionization energy, and I want to show you quick recap. We have seen this modern periodic table developments, modern periodic systematic nomenclature also completed, and moving ahead, ionization energy in general trends. Ionization energy in general trends, then we can see ionization energy from left to right in the periodic table. In the periods, it is going to be ionization energy increases in the way and decreases in the way. When you go from here to here, you can see groups, ionization energy, decreases. Across the period, ionization energy increases. That is the simplest thing you can see from the periodic table, bachcho. And you can see factors affecting ionization energy, size of the atom. Ionization energy decreases with increase in the size of the atom. Okay, and the second one, nuclear charge. Ionization energy increases with increase in the nuclear charge. Hi, Abhinav Yadav, how are you? Session ke ek baar like maro. How are you? Waiting for your result and want to continue and drop this? Okay, and screening effect. So higher the screening effect, lower is the ionization energy. And penetration power means involving capacity of the electron towards the nucleus. More the penetration, more will be the ionization energy. Penetration power of this s orbital is greater than p orbital is greater than d orbital is greater than f orbital. Okay, and electronic configuration, higher the ionization energy for fully filled or half filled electronic configuration. So the elements with either completely filled or half filled is going to have the higher ionization energy values. Understand? So these are the factors, and we will discuss about the various applications of the ionization energies and other periodic properties in upcoming sessions. Hope you enjoyed today's session, all the students. Also, Abhinav, Navashi and Kushal, Anil and Anisha and Ahmad, all students, I enjoyed the class, especially with you and chatting with you continuously. Please like this session, share with your friends and subscribe to Infinity Line NEET YouTube channel. So we are all done from our side. Thank you very much. Signing off, Suresh, Faculty of Chemistry from Infinity Line. Thank you very much, Bacho. Bye bye. See you, meet you soon. Okay. Thank you. Bye bye. Take care.